Hello everyone. Today we want to have a dynamics question in physics, and then so it's an interesting question. So we have two masses on the ramp; those are connected with a pulley, and then so one of the ramp's angle is given, but the other one is unknown. Then we have to calculate that. So these are all information we have in the question. The coefficient of kinetic friction is 0.21, and then the acceleration of the system is going to be 0.283 meters per square second, and toward this side. Okay, so then I have two masses connected to each other, right? So then the first step, I have to draw the free body diagram for every single mass. So then on M1, which is this one, so I have one force which is always perpendicular to the surface, that is called Fn. So then this is Fn. And then also I have another force, which is gravitational force and always downward, which is mg. And then also I have another one opposite to the motion, that is called kinetic friction. And then there is another one connected to the rope, which is called ft, which is tension force. Now, so I have to do the same for the other mass. So then I have Fn, then I have mg, but which m it is m2g. This one was m1g. And then also I have ft, and then I have fk here if I assume the motion is going to this side. Okay, now so as you can see, I have these two forces, these two gravitational forces, diagonal. So then I have to break this down. So then if I want to break this down, so I have this much mg cosine theta, I call this theta. And then also I have this much mg sine theta. And so it's the same story for the other mass. So then these are M1, and then the other one is, so I have mg sine 39, and then also I have mg cosine 39. Okay, now I have all forces and then like as free body diagrams. Now I have to calculate acceleration for the whole system. But so there is a key point in pulley questions. So for pulley questions, because so I have those masses connected to each other with the same rope, then if we have any motion towards this side, so then those two masses moving together, right? So then I can calculate this for example, for M2. So as you know, the mass is not moving vertically. So then AY is 0. So then sigma Fy, which is equal to MAY, is going to be 0. And then Fn, so Fn is going to be like Fn minus mg cosine 39 is going to be 0. Then Fn is going to be m, so this is m2 actually. So then m2g cosine 39. So then this is Fn for mass number 2. And then for mass number 1, so AY still 0. So then I have Fn minus m1g cosine theta is going to be 0. then f of n equals m1g cosine theta. Now, so I have these two f of n here. Then what I need those for, because I need to calculate f of k, and then f of k, we know f of k is going to be mu k times f of n. So then f of n, we need to calculate f of k. Okay, now we need to calculate the like all forces along the horizontal axis, and which causing ax for us. So then sigma fx equals to max, and then because the masses moving together, so then I'll have sigma fx equals to m total. Okay, now all forces, so I have to consider all forces along the horizontal axis. And then the key point for pool equation is this: if I get this as x-axis, so then this also is x-axis. So it is kind of like a bended axis. Okay, so then I have all forces going this way is going to be positive, and also all forces going this way positive. And then if we have like any backward forces, then it's going to be negative. So then I have positive mg sine 39, and then minus ft minus f of k is going to be mu k times f of n, which is m2g cosine 39, and then plus f of t minus m1g sine theta minus mu k m1g cosine theta. So then that is this equals to m1 plus m2 multiplied by 0.283. Okay, now we're looking for theta for these ones. Okay, now let's make them a little bit simplified. Okay, so we have m, so this is m2 actually. Okay, so then m2, which is 12 times 9.8 times sine 39, it is 0.63 minus, so f of t, I have minus f of t here is plus f of t, so then it's going to be cancelled out, and then minus mu k is 0.21 multiplied by m2g, which is 12 times 9.8, and then times cosine 39, which is 0.78 almost, then minus m1g, which is 8 times 9.8 times sine theta minus mu k is 0.21, m1 is 8 times 9.8 times cosine theta equals this is gonna be 20, then 20 times 0.283, it's gonna be 5.66. Okay. So 5.66. Now we need to solve for theta, right? So then we have to have some math skills. So let's calculate these numbers. So 12 times 9.8 times 0.63. So this is gonna be 74.088 minus, then 0.21 multiplied by 12 multiplied by 9.8 multiplied by 0.78. And also this is 19.26 minus, so 8 times 9.8, so it is 78.4 sine theta minus 0.21 multiplied by 8 multiplied by 9.8, so then it's gonna be 16.46 cosine theta equals 5.66. Okay, now we need to solve this. So these numbers, so like 74.088 minus 19.26, so it's gonna be these numbers. These numbers is gonna be 54.82, and then also I can take this 5.66 to the other side, and it's gonna be minus 5.66. So then minus 5.66. So that is equal to 78.4 sine theta plus 16.46 cosine theta. Okay, now if I subtract 54.82 minus 5.66, it's gonna be 49.71. Then 49.16 equals to 78.4 sine theta plus 16.46 cosine theta. Now I can isolate one of those variables because I have one equation here. However, I have two variables, right? So then I can isolate one of them versus the other one. So for example, I can have 49.16 minus 16.46 cosine theta equals 78.4 sine theta. Then sine theta is gonna be 49.16 minus 16.46 cosine theta divided by 78.4. Now I have sine theta here, right? So if you remember, we have like one of the most common and practical trigonometric identities is this: sine squared theta plus cosine squared theta is 1. Now the only thing I need to do is, so I have sine theta here, then so I can solve sine squared theta and then plug in into this formula here. Like here. Okay, So now let's have sine squared theta. So then sine squared theta, so it's gonna be this. So I have 49.16 squared, which is gonna be 2416.70, then minus 2 times 49.16 times 16.46, so which is 1618.35 cosine theta plus 16.46 squared 270.93 cosine squared theta divided by 78.4 squared, which is 6146.56. Now I need to plug in this amount into this formula, then I have only cosine theta. So then I have so I'll write that here. So I have 2416.7 minus cosine theta plus 270.93 cosine squared theta divided by 6146.56 plus cosine squared theta is 1. That's it. Now I can solve this. This is a quadratic equation, right? So the easiest way is multiple each term by 6146.56. So then I'll have this 2416 minus this cosine theta plus 270.93 cosine squared theta plus 6000 cosine squared theta equals to 6146.56. That's it. So then these two like terms, right? So then I have 270.93. So then I can rewrite this better here. 6,417.49 cosine squared theta minus 35 cosine theta. And then also I can do like these terms simplified, right? So then I can take that to the other side. So it's gonna be 6146.56 minus 2416.7. Then it's gonna be minus 3729.86 equals to 0. That's it. So then solve this quadratic equation. Then you're gonna find like cosine theta. Once you solve this, then cosine theta is gonna be 0.80, like this almost. And then theta is gonna be cosine inverse of this number, which is gonna be, based on my calculations here, is gonna be almost 26 degrees. That's it. So I hope you enjoyed this session. Please comment me if you need any more information. And then, so I hope to see you all in the next class. Thanks for watching.